In the last video, we drew the background and placed a spaceship sprite on top of that background, but it didn't do anything. We're about to change that. We want to allow the player to control the spaceship. We're going to do this by using flags. A flag is a variable that is set to either true or false, and they are used to let different parts of the game program know that something has happened. For example, the gameActive variable is a flag. As long as this is true, we will repeat through the game loop. But as soon as this is set to false, we're going to exit the loop and then exit the program. We will use flags to tell the game when the player is trying to move the spaceship left or right. These flags are defined during the initialization phase of the sprite, and their default state is false. If the user is pressing an appropriate button, we'll set the corresponding flag to true, which will lead to a change of position. If we look at the user input phase of the game loop, we already have a loop that runs through the events. An event is simply something that causes a change that Pygame is looking for, and it includes key presses, mouse movements, button clicks, and other things like that. As we loop through the events, we're looking for specific actions, such as closing the window. And if we find one of those actions, we can then make our game respond appropriately. If you wanted to see what the events look like, you can uncomment the print event command, and the events will be printed in the console. But it turns out that holding a key down isn't an event, and we don't want the player to have to press the button repeatedly to move. So we have to add another command to look for that type of user input. The getPressed command basically tells Pygame to determine which keys are pressed and which ones aren't. This creates a tuples of zeros and ones. Pygame has a collection of constants that map this tuple to different keys, and the full list can be found in the documentation. The two keys we care about are the left and right arrows. If these keys are pressed, then we set the corresponding flag to true. Nothing will happen with that flag until we update the game state. Notice that we've added the allsprites.update command into that phase of the game loop. Remember that allSprites is a sprite group that contains all the sprites, and this command will run the update method for all of them. At this point, we don't have an update command for the spaceship class, so we need to add one. The first thing we're going to do is adjust the spaceship's rectangle based on whether the player pressed left or right. The amount that we've shifted is a variable called speed that belongs to the sprite. Just as with the game constants, this allows us to make one change and have the speed change everywhere, which makes it easier for us to alter the game. If we stopped here, the spaceship would be allowed to go outside the game window, and so we need to add some code to keep it inside. We can refer to different parts of the rectangle to give us better direct control. This diagram, which we saw earlier, helps us to control the position of the rectangle. If the spaceship is sticking out the left side of the screen, we'll snap it back so the left side aligns with the edge of the playfield. And if it's sticking out to the right side, we'll snap it back so that the right side aligns with the right edge of the playfield. Using the same ideas, you can also make it so that the spaceship can move forward and backward, but for this game we're going to restrain the movement to one axis. If you were to run the code with only these changes, you would find that the spaceship is basically uncontrollable. The problem is that the game loop currently cycles through as fast as it can, which is likely hundreds of times per second. The game is simply going way too fast to be played. So we need to add some code to slow things down to a manageable speed. At the beginning of the code, we'll add a new constant FPS, which stands for frames per second, and we're going to set our speed to 60 frames per second. We will initialize a clock, which is how Pygame keeps track of the passage of time, and then we'll add a new command that controls the game speed at the beginning of the game loop. You can think of this command as a traffic cop, making sure that the game slows down so that it doesn't go faster than 60 frames per second. And with this in place, our game will have a much more controlled feel. If you want to change the speed of the spaceship, you can adjust that by adjusting the speed in the class initialization. Another thing that we can do to add interest to the spaceship is to introduce animation. This is a place where the skilled artist can have a bit of fun. I'm not a skilled artist, so I'm just going to have the lights alternate colors. However, the process that we're going to set up will allow you to have animation loops that can be as many frames as you want. In order to do this, we're going to create a variable that counts the frames. And then every time we pass through a certain number of frames, we're going to change the image. So the two new variables we're going to introduce are the animation frame and frame count variables. The first one tells us which frame of animation we're on, and the second one just counts how many frames the sprite has existed for. We will also need a list of images for our animation, and all of these commands will go into the initialization. Every time the update command is run, we're going to increase the frame count by 1, and every 30 frames we're going to change the image. The percent symbol is known as modular arithmetic, and this just gives the remainder when performing division. So on frames 30, 60, 90, 120, and so forth, the animation will change to the next frame. And since there are 60 frames per second, this is changing every half second. If this code feels a bit confusing, don't worry about it. The code is set up so that the only things you need to do are load the images and put the images into the list of animation images. Everything else should happen automatically. At this point, we're starting to have something that really feels like the start of a game. You should try running the code and changing some of the parameters to see how it affects how the game feels. You might also want to see if you can figure out where to change the code so that the next frame of animation appears every 10 frames instead of every 30 frames. Before we start adding additional features, such as lasers, we're going to take a moment to make our code easier to work with. That's the topic of the next video.